This is Geometry, Unit 3. We're going to talk about algebra proofs. Today is the first day that we've used the proof word. We're going to be talking about proofs. Today we're going to mainly talk about algebraic proofs. So a proof, down here, a proof is an argument that begins with known facts and proceeds through a series of logical deductions and ends with the thing you're trying to prove. So you got to make a logical statement and you got to work your way through to reach a conclusion that you're looking for. When you read a computer program, it's very much like a proof. You have to write things in a correct order. Your notation is important, and you're trying to get to have your program produce something specific. So that is a great relationship to how am I ever going to use this in a computer program or even in recipes. If you go in a wrong order, it's detrimental to the result. Lots of things are in that format. We're going to do something called a two-column proof. A two-column proof always has two columns, believe it or not. One column is for statements, the other column is for the reasons. Statement and reasons. So we're going to talk about the properties for the algebraic properties of equality. So here we have two items. A equals B. You can think about that maybe as A, let's call it 2x minus 3 equals 9. Okay, so we have two sides. We have this side over here, which we might call A, and then we have this side on this side of the equal sign called B. If A equals B. That's what we have here. A equals B. Then we can add the same thing. This is how you would do your algebra problem. Back from algebra class. This is why you learned it then. You added the same thing to both sides. That process of adding both things to both sides is called the addition property of equality. When you add the same thing to both sides, and you're left with 2x equals 12. The process of going from 2x minus 3 equals 9 to 2x equals 12, you went through the addition property of equality. You can think about it like a Harry Potter spell. And you're there and you see what you have coming at you, 2x minus 3 equals 9, and then you try to get all dramatic and say something like, addition property of equality. And that switches it over and now it's 2x equals 12. You change the format of what it looked like by giving the magical spell. These are all different magical spells that make the mathematics change. So we have subtraction property of equality when you subtract the same thing. Multiplication property when you multiply the same thing. We have division property of equality. So when you're starting out with A and B, of course C cannot be 0 because you're not allowed to divide by 0. But when you have A divided by 0, that's going to be the same thing as B being divided by 0, if in the beginning they both were equal to each other. Two more, a little bit more complicated, is called this substitution property of equality. Notice how this one has A equals B. If you are the same height as I am, and I am the same height as somebody else, so if A equals B and B equals C, then you're the same height as the other person. A equals C. We substitute the C in place of the B. You remove the B and you put the C in its spot. So A equals C. That's substitution. You can only do substitution when you work with equality, equal signs. Distributive property of equality. You know this back from algebra. When you distribute in, you then have a times b and a times c. That's called the distributive property. Even if you work the other way and pull the term out, it almost sounds like a factor property of equality, but we're going to call that the distributive property, even when you work the other direction. So let's give this a try. Let's write a 2-column proof for this algebra problem, given reasons for all the steps we take. So a 2-column proof is going to start out with a giant T, and on the top of the left side is going to always be statement, and the right side is going to be reason. Or you can put that plural if you want, reasons. Sometimes you might see it written as justification, but reasons, just a simpler word perhaps. So when you start out with any proof, you're going to look at the information that they give us. Here in the beginning, they're giving us this information. It's called given. In the future, you might actually see the word given, and then it'll share stuff that they're giving you to know ahead of time. So this is our given. 2x plus 3 equals 9 minus x. So that's going to be our first statement. 2x plus 3 equals 9 minus x. And the reason we have that on our paper is because this comes from the given information. The first reason is most always going to be given, because that's what you're starting with. Now, this is an algebra problem. What steps would you take? You do have a choice in which one you want to do first, but what steps would you take to solve this algebra problem? Any suggestions? You could subtract a 3. If you want to show, physically write that in here, you're welcome to. You don't have to. That's the kind of the neat part. So what we're going to have for statement number 2 is the 2x, the equal sign, 6 minus x. So what did we do? How did we go from 2x plus 3 equals 9 minus x, and now we have 2x equals 6 minus x? What happened in that step? Very good. It's going to be the subtraction property of equality. And you have to write down all 4 words. Subtraction property of equality. We're going to write a lot more words than that in the future. So don't be afraid of using and writing out those 4 words. There will be an abbreviation in the future for property of equality. Try to use it for at least tonight. Number 3. What might our next step be? What do you see up here? What's our steps going to be? You could physically do it here if you like to. Or you would just write 3x equals 6. And the magical step that we had from statement number 2 to statement number 3, what did we do to produce that? We had the addition. Property of equality. And how do we finish this off? What's our final steps? We would divide. And if you just want to say x equals 2, there are no expectations that you show your steps. Your steps are the reasons. Your steps are over here. Division property of equality. And there you've done it. You've completed your first proof. That is a 2-column proof. You start out with your given. You show your logical steps until you get down to your conclusion. Let's try another one. So here's our algebra. This is our given information, of course. So we're going to take a 2-column proof, start out with statement, the second column is reason, so take the time, write out the big table, put the words at the top, give yourself some room. 3 times x minus 5 minus 2x equals 21 plus 10x. So you get it all to fit in there. And your number one reason, your first reason, where did this come from? How do we know that? It came from the given information. Reason number one is really simple. We always can answer that one. So we have some choices. We could use distributive property, but we also have some like terms. And if you ever have like terms, I suggest going with that first. So I'm going to add my 2 x's across. Notice I'm going on opposite sides of the equal sign, so I'm going to do opposite the minus 2x, so it's a plus 2x. So my my next statement is 3 times x minus 5 equals 21 plus 12x. And my reason for that, we added. So it's called the addition property of equality. Now, really the only choice that we have, we could maybe get away with division here if you divide it, because everything is divisible by 3. Now would be a good time to use division. But we can also use the distributive property. So let's use that. We haven't used it yet. So 3x minus 15 equals 21 plus 12x. So that magical step is called the distributive property of equality. Okay, what would you like to do from here? You got to make some decisions on your own. Choices. What choice do you see? Okay, we have some like terms that we can add together. So if you want to physically write it in here, you're welcome to do so. You don't have to, but it does help you for making silly mistakes. So you have 3x, the 15s are crossed out, you have your equal sign, 36 plus 12x. And that was, you can physically see what you did, addition property of equality. Some people get confused that, hey, we used addition already. It's okay, you can use addition multiple times. However many times you keep adding things to both sides, you can keep using that magical spell. So here, we would probably subtract our 12x across. I don't like making x's negative, but I don't want to go through 2 different steps to get there. So I'll take my negative value, extend my table down, and we've got statement number, that would be 5 now. So 5 was subtraction property of equality. And then our final step will be number 6. We will divide, and we get the answer of -4. And that was division. Property of equality. So we're going to flip this page over. We're now on page 3. My chart got blocked off here a little bit. The reflexive property. If you have a value, it's a single value A, then you know that A equals A. That's the reflexive property of equality. Here, in terms of a segment in geometry, this segment is the same side that's in both triangles. We're going to look for this in the future in geometry problems. When you have the same side shared in both triangles, we're going to call that where AB equals AB. And that's called the reflexive property of equality. When the same thing equals itself. When this side of that triangle, the left one, equals the same as the right side. We can also do it with angles. You see that angle B in the small triangle would be the same as the B in the large triangle. So you could say that the measure of angle B equals the measure of angle B. That'll make more sense when we get into more geometry problems, but the B in the small triangle is the same measurement as the B in the large triangle. That's because it's the same angle. And that concept is using the reflexive property. There's also something called the transitive property. And since this is of equality, we don't use it a ton. We use substitution in its place. But if A equals B and B equals C, then A equals C. There's a bit of a mistake in here. We're missing a line. If you have these 3 angles, that's a part that you're always going to see about transitive property. You're always going to have 3 parts. If segment AB is going to equal this DC, and DC equals EF, then you know that AB is going to equal EF. Same thing for angles. If the measure of angle A equals the measure of angle B, and the measure of angle B equals the measure of angle C, that kind of fell off my page apparently, so that needs to be put back in there, then the measure of angle A has to equal C. We're working our way around the B. So we'll come down to our final properties and see what we think about writing those in. We're supposed to use the transitive property of equality. So if R equals S and S equals 44, then what would we give as a reason if we're trying to mirror the transitive property of equality? We know that R equals 44. If R is the same as S and S is the same as 44, then R is the same as 44. That's the transitive property. The reflexive property. You know reflexive is going to be just like a mirror. So if you're working with the measure of angle N, what's your other side of the equal sign going to be? It's going to be the exact same thing, the measurement of angle N. The reflexive property just says that they're both equal to each other. They're the same thing, so they're equal to each other. addition property of equality. This notation's kind of funny looking. It's showing you what you're adding to both sides of the equal sign, because I want to be sure that you know that there's going to be the same. If you know that RS is supposed to be the same as TV, then when you add XY to RS, you would need to also add XY to the TV to keep it equal. So that's the addition property of equality, when you're adding it to both sides. And then our final one here is substitution. If you know that the measure of angle 1 equals 20, and you know that the measure of angle 1 plus the measure of angle 2 is involved, then we are going to substitute in the 20 for the measure of angle 1. Then you could continue on and solve it if you knew what they added up to equal. But that's called substitution, when you remove the one piece and you plug in the other half. These two guys equal each other, and you remove anywhere you have the measure of angle 1 and you replace it with 20, because angle 1 is 20.